All right, hello. This is the Math 8 Unit 1 Common Summative Assessment Study Guide. It's September 24th, 2019. And we have our study guide here. Number 1, Bob the Builder is creating a new housing development in Madera, California. The model homes are going to be built and showed to future buyers. Bob wants to make sure that the homes on both sides of the street are exactly the same. Part A. Plot the following points of the second house. So our first task is to plot these 5 coordinates on this graph over here. So we go from the origin to the right, 1 down. Origin, 1, 2, 1 down. 6 to the right, 1, 2, 3, 4, 5, 6, and 1 down. 2, negative 4, 2, 1, 2, 3, 1, 2, 2 to the right, 1, 2, 1, 2, 3, 4 down. 6 right, 4 down, and 4, negative 6. So we're going to connect these dots. The next thing we would want to do is to identify that we have a pre-image. And we have an image. So we're going to label that. We're going to label this as A, B, C, D, E, and give our coordinates, negative 5, 4. B is negative 3, 6. C is at negative 1, 4. D is at negative 1, 1. And E is at negative 5, 1. We're going to hold off on calling this A prime, B prime, C prime until we look at what we need to do our task in part B. Use all 3 rigid transformations. Oh, whoa. So let's look at this word rigid, meaning stays the same. So we know 4 total transformations. The 3 rigid transformations are translation. We can translate is to slide. We can rotate is to turn. Or we can reflect. And that's to flip. We have a lot of good options with this figure right here. We can do lots of cool things. One simple one would be to look at, this is the x-axis right here. So it's important to identify the x-axis and the y-axis. And you can see very simply that we could do a reflection over the x-axis, where this would flip over. We could then translate it. That would be only 2, though. We need 3. So let's do, instead, if we do a reflection over the y-axis, then if I reflect over here, I'm going to have 4 points. 1 here, 1 to the right, 1, 2, 3, 1, 2, 3. This is negative 5, 1. My rule would say it would be positive 5, 1. Positive 5, 4. So this would be a reflection Okay, that would be a reflection over the y-axis. And even better than just say reflection, you could say the house is reflected over the y-axis, or you can say polygon A, B, C, D, E is reflected over the y-axis. So there's one. So I need to have a second one. I can then rotate this all the way around. I'm going to draw this as C prime here. B prime, A prime, D prime, and E prime. Okay, so if I redraw this figure using some patty paper, I'm going to make sure I put down the letters A prime, B prime, C prime, D prime, and E prime. I need to get this in and we need to put, of course, we need to put the origin down because we're going to rotate about the origin. Origin's right there. So I'm going to turn this until the orientation looks the same. There's one turn. It's not quite right yet. And I'm going to turn it one more time. So that's a two turns. Two turns is 180 degrees. And I'm going to redraw this. I think I've drawn one of these off. That's the trouble. I made an error. Here we go. And that one's in. So one way to check is to make sure that you've got all of the same distances. So 1, 2, 3, 4, 1, 2, 3, 4. It's still congruent. 1, 2, 3, 1, 2, 3, 3. This goes 2 and 2, 2 and 2. Got it. So I just need to get down my letters here. B double prime, C double prime, D double prime. This is E double prime and A double prime. So I did a rotation. Now I need to know how many degrees. 180 degrees because it was two turns. And I went in this direction, so that is clockwise. Okay, my last thing is just to describe the translation here. This is going to become B 3 marks, triple prime, C triple prime, D triple prime, E 1, 2, 3, and A 1, 2, 3. Now I don't have to make it complicated here. I just need to move this E to the right. And how far do I move it? Let's count. 1, 2, 3, 4, 5, 6, 7. So I went, all the x coordinates are going to move 7. Let's check this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that's just simply a translate the image to the right. Again, it was 1, 2, 3, 4, 5, 6, 7. 7 units. the rule for that would be x plus 7. Are the two houses congruent? And justify your reasoning. The answer is yes. The two houses are congruent, and you can use the congruent symbol if you want. Okay, and it's because they are mapped by a series of transformations or rigid transformations. You could also name the three transformations. You could name them the transformations and then put a colon and put translate, rotate, and reflect. But they're up there anyway. If you had put them, that would have been super. That would be that would be a full point response. On the test, you'll see a similar figure. The image position will be in a different orientation, and you have to come up with your own three rigid transformations. Number 2. Jessica is resizing a photo for the school yearbook. Okay. She wants the images to be similar. Okay, well, what do we know about that? We know that images that are similar are going to be have the same angles, but they'll be proportional. Okay. Using a series of transformations, prove if the images are similar to each other and justify your answer. Okay, what's really nice on this problem, we have a rectangle, and it looks like first thing we want to do is check out the sides, and then we can think about how are we going to move this object up here because we're going to need to dilate it. Well, first let's give it some points. A, B, C, D. Okay, so I'm going to locate this as -8, -1. This looks like 1, 2, 3, 4, 5, 6. 5, 6. So that's 6, -1. That would be 6, -5. Oh, I made a mistake. I'm sorry. -6. I'm going to put my glasses on. Sorry, -6, -1. I'll just rewrite that. -6, -1. And this is -6. -5. That's a 5 also. -6, -5. Okay, so we are going to come up with an idea of how to move this. Now, if I see that I have a point here, I can move it. If I translate it up to the origin, it looks like we have 1, 2, 3, 4 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. It's a rectangle, so all my angles are 90 degrees, which is nice. And so is my image. So I already know that first I need to prove that they are similar. I need to know that they're both images are rectangles. So all the corresponding angles are congruent. And I need to count here. This is 2 units. 1, 2, 3, 4, 5, 6 units. And if I call this A prime, B prime, C prime, and D prime, then if I'm doing corresponding parts and relating the large figure to the smaller figure, I can, or the small figure to the larger figure, This is the image, that's the pre-image, so let's do it that way. I'm going to do some fractions here. 2 is to 4. 2 over 4. Is that equal to, I'll put a little question mark, 6 over 12. Okay, well this is the equivalent of 1/2, and this is 1/2. So are they proportional? And the answer is yes. So if I have proportional sides corresponding, and I have congruent angles, I have similar objects. Now I just got to figure out how to move the figure. I'm going to move it up to the origin. 1, 2, 3, 4, 5. So I'm going to translate the image. One, 2, 3, 4, 5 units up. Okay, and then that's going to give me these coordinates here. If I move this to here, then I would have this point would be at -6, 0, and then this is at -3, 0. This is at +3, 0. So if I move this up 6, and I need to dilate it and shrink it down, this would be if I go up 5, I said 6, I meant 5. Then it would be at 6, 0, and I need to shrink it to 3, 0. Let's move this one up 5. 1, 2, 3, 4, 5. Think of this point right here would be 6, 4. And I need to shrink it down to 3, 2. And if I move this point up 5, 1, 2, 3, 4, 5, I'd have a point 6, -6, 4. And I need to shrink it down to -3, 2. That looks like it needs to be shrunk by times a half, times a half, times a half, times a half. Okay, that'll work. And if I go -6, 0, and +6, 0 by moving up, if I multiply that by a half, I get to there. 0 times a half is 0. Okay, that'll work then. Translate the image 5 units up, and then dilate by a factor k equals 1/2. There's other types of transformations you could have performed at the beginning because it's a rectangle, but that was the simplest. On the back. Given that line segment WT, that's what this symbol means, is parallel to line segment YP. So let's identify that. I have YP here and WT. I already have the parallel lines. That's really important. So I usually mark that with red, saying that that's parallel. Why do I do that? Because then I can identify the interior. That makes this a transversal line. We'll call it transversal 1. And then here's a transversal 2. Why is that important? It's going to give me congruent angle here and here for corresponding. The alternate interior angle and vertical angles are going to be congruent. These are all going to be 80. So this is usually what I do to begin with. I know a triangle adds up to 180, so I'm already starting to think, okay, I need 80 plus 43 plus another measure, QRE. Those are going to add up to 180. So this is 123. I'm going to do a quick subtraction here. That's 7, borrow 57. So this measure here is, I'll give it 2 marks. It's 57 degrees. And that looks reasonable. I look at the angles. That's close to 90. So they're all 3 acute. That's nice. Corresponding, remember this is a transversal line. We identified the interior. This is the exterior. So we have corresponding angles. So we know that that's 57. We know there's 2 ways to know this angle. It's a vertical angle, and it's also alternate interior angle. So but just by looking at it, vertical angles, crossing lines, these are always going to be congruent. 57. What do I know about a straight line? I know it adds up to 180. I know that I've already figured out that this is 100. This has to be 123 and 123. Here's its alternate interior angle. Here, let's give it 3 marks. 1, 2, 3. 1, 2, 3. 1, 2, 3. So this is 123 degrees. Well, we've already named almost all the angles. This is a straight line. This is 100. This is 100. This will be 100. Remember, these are alternate interior. And so we were given just that little piece of information. We were able to find out all these angles really fast. Calculate the measure of QIP. Now I just got to figure out where that is. Let's find QIP. 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 3 letters. Remember that the middle one, I, is the vertex. That's where your angle is formed. We've already found the angle, but now we need to justify. There's several different ways you can justify. You would have to start with the fact that a triangle, first we know that triangle, this is one possible method. Triangle EQR sums to 180 degrees, and we already did it up here. So I would either draw an arrow or just rewrite it. I could write a very fancy statement, but this will do right here. I know that 80 degrees plus 43 degrees plus the measure of angle QRE equals 180. So I know that measure of angle QRE equals 180. So once I knew this angle right here, the easiest way to do it is to go to the corresponding angle. And so I would say that angle QRE is congruent to angle, so there's QRE is congruent to QIU, or you could say RIU. We'll just do angle QIU because they are corresponding angles. I'm out of room, so I'm just going to write the angles symbol. That's an angle. You can also put an arc through it. Corresponding angles are congruent. Okay, I'm almost done then. Now I can see right here my last statement. QIP and this angle QIU, these two angles add up to 180 degrees. And I know that I made a mistake here. I'm sorry. I know that angle QRE is 57 degrees. Okay, and then I know that they are congruent, so I know that since they're congruent, the measure of angle QIU is equal to 57 degrees, since they're congruent. And then my final statement is the measure of QIU plus what we're looking for, the measure of angle QIP. When I add those up, that adds up to 57 degrees. I'm sorry, 180 degrees. And I can substitute in here 57 here. 57 degrees plus this measure add up to 180 degrees. And so therefore, I'm just going to put the final answer right here. And this is the symbol for therefore. Measure QIP equals 123 degrees. And there's my answer. That's a full point response using angle properties. You could have done, in our class, we introduced vertical angle, and then some side supplementary. That's very difficult. But you do need to use the triangle angle sum, and likely on your test, you'll have something similar to this. And that's the simplest method to it. Okay, the final answer. Essential question number 1. How do you know when two figures are congruent? Okay. How do you know when two figures are similar? Okay. We know for number 1, you know that two figures are congruent. If you want to save space, you can still use the congruent symbol. If a series of transformations map one to the second. And you could say a series of rigid transformations if you want to be even better. Or you could name the 3 transformations. You could name rotation, reflection, and translation. The second one, two figures are similar if a series of rigid transformations and a dilation occur, or can be used to map an image to or a pre-image to an image. You could also mention the angles are congruent and the sides are corresponding are proportional. That's sorry I wrote that so small. Essential question 2, how are angle relationships useful when comparing the angles found in parallel lines cut by a transversal? Okay. And then this, it's very simple. The properties of parallel lines cut by a transversal can be used to calculate missing angles. And you could name some of those properties if you wanted to: alternate interior angles, corresponding angles, vertical angles, supplementary angles. Those are all properties that we used. That's where we built the property. The other essential question, the triangle is built through the 2 parallel lines cut by 2 transversals. In this case, you could see if I was to draw a parallel line going this way, where the 2 transversals intersect, creates this triangle and creates these properties. Okay, and that ends the review. Good luck. Your test is tomorrow.